Good morning, everybody. Sorry for the delay. We had some technical difficulty getting the audio working. That's what it took about a couple of minutes to get everything rolled into. Good morning, everyone, and then welcome to the DB2Night show, episode 270. Today, we are excited to dive deep into one of the most mission-critical aspects of any enterprise database environment, availability and recovery. Whether you are managing an OLTP, supporting hybrid cloud deployment, or overseeing DR readiness. Today's session is packed with insights, or you don't want to miss it because you want to learn everything about how transaction log works, how DB2 works with it, what are the enhancements provided within DB2 12.1.2. That's what we're going to talk about. We have Martin Hubel, my co-host. Hi, Martin. How are you doing?
Doing great. Thanks for asking.
Awesome. And we have a special guest, Michael. How are you doing today?
Very good. Thanks for having me.
Oh, great. Thanks for offering this help. And this is really good for the community to know more about the features available within DB2 transaction logs, the backup recovery, and all that. Resilience makes a lot of difference in the environment. Get involved. Please do follow us on Twitter, X now, and then the DB2Night show on YouTube, as well as please do join us on LinkedIn. The links are provided here. Disclaimer. Tonight night show, the quick announcements we have, and then we have a little bit of audience poll and the presentation question answer. So any questions you have on the topic we're discussing, please do post in the chat. I will be able to read it out to Michael, and then Michael will address it at the end of the presentation. We have a lot of sessions coming, all from lab, right, this year. The one which we're doing currently, 270, that's what Michael is doing about the availability recovery. Get ready for what next. We have series of other sessions from the lab. Don't miss it. We'll send out all the communication links in LinkedIn and external emails. All right, so thanks to our sponsor, DBI, Smarter Tools for Smarter People. DBI product works for both DB2 and SQL Server. A good product for a performance tuning aspect of your database. All right, so you will start seeing polls coming on your screen. What version of DB2 you're currently using or running? You have 30 seconds to provide the response. All right, so getting the responses. Gonna be closing the poll in 3, 2, 1. Closing and sharing. So we have mixed here, but pretty good, about 11, 5, 8 and higher. 25% or lesser. Yeah, that's good.
You got to start putting 12.1 in there. So.
Yeah, I need to put it now. Yeah, exactly. So I need to put that number now. Are you planning to upgrade to DB2 12.1? All right, collecting the responses. Yep. Awesome. Great. Closing the poll, sharing the result. 75% says yes, and 75% say they want to know more about DB2 12.1. That's why you're here.
I don't know, hopefully I can convince some of them.
Yeah, exactly. And then we had multiple sessions from Mike and everybody else on the DB2 12.1 features overview. Please do refer back to the replays. What are your environment challenges? For sure, I'm going to get that 1 and 2, the performance and availability. Let's check. Distributing poll. right, collecting the responses. Gonna close the poll. 3, 2, 1. Wow, 33%, right? It's pretty decent. Performance, availability, and data growth. Yeah, Michael is going to talk about availability, resiliency. That's what we can discuss more today. All right, that's what we have for poll, and let's move on to the next. Okay, awesome. So with the 12.1, with bringing cutting-edge enhancements for HA and DR solutions, transaction logs, backup operations, advanced log management, intra-partition parallelism to improve the backup performance, these are the innovations which are delivered within 12.1 to make the DB2 work faster and smarter. We are now honored to have Michael today, a senior software developer for DB2 availability and recovery at IBM Toronto Lab. Michael has been instrumental in architecting, implementing many of the availability and recovery features we rely on today. His deep understanding and experience will give us a real look behind the scene at what's next for DB2 in ensuring maximum uptime, faster recovery, and smarter log management. Let's get ready to have this masterclass going. Over to you, Michael. I'm going to make you as a presenter.
All right, awesome.
You to see a pop-up coming?
Yep, show my screen. And do we see it?
Yep, I do see it, full screen, yeah.
Great, awesome. So I'll just go through a little bit, and then every once in a while, I guess I'll just check in and see and ask if there's any questions in the chat. Okay, I'll come back to that as we go through. Okay, I'll dive right in. Okay, thanks for having me. It's always great to come and talk to the group about any new features that we come up with. 12.1 came out the door, I believe it was last year. Mod 2 we just shipped a couple of weeks ago, so we've done a lot of work. And let's jump in and talk about all the good stuff. So this deck has a lot of content. Some of it obviously is about what we just did in 12.1 and what we just came out with in Mod 2. At the very end, I do have a little bit of forward-facing statements on what we're hoping to come out with our Mod 3 that's currently scheduled for end of this year. So I have a couple of items there, but like always, anything in the future can change. So this is just our typical statement that whatever you see now may or may not happen, but we like to try to make it happen. So overall, everything, this is, like I said, packed. 12.1 was a long time in development for us, about almost 3 years. So over that time frame, we accumulated a lot of new feature work that we did. Some big features that we're going to go through, ITP, Intra-Tablespace Parallelism, being the focal point of what we've done from the team. But as well as lots of other maintenance operations, trying to make your life easier, doing things that are a little bit more autonomic, making you aware of internals that could be causing you problems down the road that you might not be aware of. A lot of different things in that nature. As well, we have a lot of internal knobs or things that were off by default that over time we've tested and made sure that it's steady and sturdy and robust. And it's about time that we bring that out to general market. You know, a lot of times we have a lot of features available, but they're not on by default. And I come to these sort of meetings, if it's iDoug or conferences like this or presentations like this, and people just aren't aware of some of the features that we put out there. So trying to get those things on by default is our goal, and you'll see there's a lot of that going on. Okay, so here's the list. Like I said, it's a big packed list, so we're going to go through all of it. So there's a little bit of pace to this presentation. I'll be going through quickly. But I will be going deeper in the big ticket items. So I will look for some questions here and there. But yeah, so what's new? What's changed? Like I said, a lot of this stuff. And then we've also gotten rid of a couple of things. We've deprecated and discontinued a couple of things. So I think Mike Springay last month went through what's new overall from DB2. This presentation is going to be focusing solely on availability and recovery features. Okay, and based on what I've seen, we're a big part of what's been coming out new. All right. Okay, so what's new? ITP, Intra-Tablespace Parallelism. That was the big one. So the big problem today, if you look at this, was our old process model for backup. What you can see here is we have a DB2 agent that's down the middle. And the DB2 agent was communicating with our buffer manipulators on the left that is reading data from the database, and our media controllers that are dealing with the devices and writing the data on the right. So what typically would happen is you get an agent, the agent creates a bunch of buffers, it asks the BMs to read, we populate the buffers, supply them to the media controllers, and the media controllers write them out. So what happened was with the buffer manipulators, the BMs, or I'll call them BMs for short, they have a one-to-one mapping with the parallelism parameter at the backup time. So what that means is if you say parallelism 4, you're going to get 4 BMs. And what would happen is each BM would be assigned a single table space. So if you had many table spaces, of which some were large and the bulk were small, what would happen is one BM would go to the big one, a bunch of the other BMs would go to the others, and then all of a sudden the small table spaces would finish real quick, and then those BMs would sit idle. And then we would sit and wait while the big table spaces would be processed by that single BM or that single thread. And that wasn't the most optimal sort of handling. All right. So what would happen is, based on the time frame, everything would be done. And then we would be sitting there waiting as one thread is reading the data, putting into the queues, into the buffers, and being picked up. All right. So that was our bottleneck. So a lot of times we took service calls and performance complaints, and we would look at it. We'd use DB2 PD-bar stats, and we would see that, or even at the end, the bar stats and the dialog, and we would see that, we weren't performing the way we should. We were waiting too much for the big table spaces. So that was our motivation for ITP. So the solution that we came up with is there's no need to have one BM mapped to a table space. What we do instead is we're going to take the table space and break down the granularity. So here's my attempt at drawing this diagram. I'm not a very good artist. I should stick to coding. But what I tried to show here is we took the table spaces on the left and we broke them up into smaller segments or chunks. And that is all dependent on the resources that are available to us. All right. If we have lots of memory, we can break these table spaces a little bit smaller. Extend size has a factor to play as well. But pretty much this is the diagram that you get. So now what happens is instead of a BM being assigned to a single table space, it's assigned to a chunk. All table spaces, we don't discriminate, meaning everything is treated equal. We see granularity, and same with the small ones. They're chopped up into the same granularity. So this way, we're able to treat everything as equal. And once a BM is done with the chunk, it just picks up the next one. So all the table spaces look the same, big or small, doesn't matter. That allows us to perform. So now what would happen is, not necessarily will the small table spaces be done sooner. They could be, but typically it's just round robin, pick up any chunk that's available and back that up into the buffers to be picked up by the media controllers. So that allows us to perform in a more steady state and keep all the resources in the system equal, so to speak. All right. If you think about it, it's a very simple mindset, but under the covers, it was actually not that easy, only because the way that we have our data chopped up, supplied, we didn't have that granularity just was not there. So everything we had was at table space level, but we were able to break it lower and lower into data pages and do things at a data page level and then clump those together, which allows us to break up and work on smaller chunks. All right. So by default in 12.1 GA, this is available. If we do happen to see problems, there is a registry variable that you see here on the screen that can turn it off. But from what we've seen so far, ITP has worked very well in the situations of highly skewed. So like I said, if you have a couple of large table spaces and a bunch of smaller table spaces, that breakup has seen the performance of about 2 times to 3 times improvement, depending on the workloads and the hardware that you have available to you. Typically what we've seen is if you have this 70% mix. So if you have a couple of table spaces that are the bulk over the 70%, then you're seeing this performance. If you see table spaces that are pretty even across the board, so everybody's taken, let's say 20% or 30% of the system, there's not much skew. And so if there's not much skew, you're not going to see much performance improvement, if any. You're definitely not going to see an opposite effect, a negative effect. You just won't reap the rewards of ITP, all right? What we have seen, though, as well for ITP, to get the most out of your ITP, it's all about I/O capacity. So if you have channels to your disks, the more channels you have, the more throughput and bandwidth is available for us to push the data through in terms of the reading. So this way, that is where you're going to get the most benefit from the feature. So what we saw is in systems that were strapped on I/O capacity, meaning you didn't have enough fiber channel to your disk, we saw things not performing as we had expected. So that was in our initial stages. We worked with an SAP database. You'll see it in a second. And we weren't really getting what we expected. And then when we dug deeper, we realized it was the throughput to the disks. And so we improved that. Sure enough, we saw the improvements in what we expected with ITP. So definitely that's something to take a look at when moving to 12.1. If you do have skewed table spaces, you should see these improvements. And if you don't, obviously open up a ticket and we'll talk through. But the main thing would be to look at your fiber channel and your capacity to your disks and to make sure that that's where it can be and where it should be. And you're kind of, I don't want to say maxing it out, but you're as high as you can be, because that's where you're going to get the most benefits from ITP. All right. The last slide here just sort of puts everything into perspective. A visual is always good. So what you see here at the top is sort of an old system that has ITP off. And what you see here is you see up top the diagram where the disks and the CPU usage, you see how it spikes. So when we start up, we're spiking, we're flushing. I'll talk about that in a few slides as well. And then we're starting to do our steady state of backing up the user data. And what you see here is, everybody's going nuts. It's going real high because all the BMs are keeping busy. The disks are all being busy because everybody's doing their thing. Then eventually you see we flatline, and we flatline because now everybody is, we've gone steady state, which means the BMs that were working on the small table spaces have kind of finished their jobs. And what we have now is like read, write, read, write. Instead of it being all over the place and everyone trying to get the data and get things out and into the images as fast as possible, we're doing things very consistently now, but not utilizing the full capacity of the resources available. What you see in the bottom diagram is now ITP. And as you can see here now, you see all throughout the disk usage percentages, the CPU percentages, you see them going at the high levels throughout the entire time frame of the backup. And you can see here, obviously, with the picture of what I was trying to describe, you can see everybody's keeping busy constantly all the way until the end because there's always something to do for a BM, okay? And if we can see over on the diagrams, you can see here, the table space here, the largest one had 56%. We can see the times here on the left were drastically altered, or, my math is not the greatest, but it's about half, maybe 40%. So this was a bit of a contrived scenario, but you can see here the impacts of having the BMs working on chopped up data compared to a one-to-one mapping. You can see the type of performance you can get out of it. Okay, so this is very promising. This is very encouraging and very exciting. So we were just at iDoug a couple of weeks ago. I talked about this and we got rave reviews. A lot of people are pretty excited about that. And we were talking before in the survey, should I or should I not go to 12.1? Well, if you're running backups that are already taken a little long, this is definitely something to look at and be excited about, and hopefully we'll get people excited to move to 12.1. All right. So that's ITP. Because this is one of our big ones, I'll take a quick second. Mohan, are there any questions in the channel?
No questions so far, but I have a question for you. If you go back to slide number 7, when we do chunking, what is the algorithm? How do you do the chunk based on the data volume, data capacity? For example, if I have 3 table spaces, one is the regular data, one is index, one LOB, then how is that chunking going to happen for LOB table space for that matter? If it is 2 terabyte and other ones are smaller ones about 500 gig
we look at the we look at page size, extent size, memory capacity available to us, util heap, all of those factors, and we try to break up on a multiple boundary. So the fact that think whatever, all the different, we try to find a common denominator between what the common sizes are between all the table spaces, and we just break that up into those smaller chunks. We have buffer sizes. So we want to also fit the buffers accordingly. So buffers can be anywhere from megs to 2 megs to 16 megs. They could be anywhere based on what the autonomic tuning provides us, and also the CPU available and the memory available to us. So we just break that up into the lowest common denominator of how many pages we can read on boundaries to optimize each read, so that we don't get these like half a page and things like that. We want full pages, and how many we can fit into our buffers. So it's not really earth-shattering in that regard, but it was just building out the abilities and the APIs at the lower level to break things up and make sure that we have the locking and the consistency of being able to access those pages without, with ongoing changes on the system at the same time.
Got it. Thank you. So in that case, do you prefer us to have, when we have ITP enabled, is it better to have the larger util heap size allocated in the database?
In general, the larger the util heap is always the better. I had another deck that I went through at iDoug, which talked about overall backup performance. And in general, I think when we go out the door, util heap size is set automatic, but I think that automatic is quite small. So we actually go out and say increase it. I forget now if it was 30,000 or 50,000. I forget what I put in that slide deck. But pretty much we asked to update that. And then there was another thing where backups with loads, backup was always a secondary to loads. We put the preference always on to the priority on load. So, load would get more of the util heap than backup. So that also kind of hindered the amount of memory we would grab. We also changed that to make backup more of a player in the system. So now backup gets a little bit more of a priority, just because the amount of performance problems with backup, you're better off getting backup done quicker. It just has less impact on retrieving, less impact on locking, getting all of that done. So the bigger the util heap, the better. As always, what is that value? It's a sweet spot, right? And it's always dependent on other factors. So like I was saying in the other slide deck, is like you try things, don't try 20, don't change 20 things at once, change 1 or 2, do some tests. You have bar stats, which at the end in the diag logs, so you can look at historic data. And you have bar stats that you can run through DB2 PD while the backup's going on, and you can see what's going on live, okay? And you just kind of monitor that over time and then see what works best. Try a bigger util heap, and you see if you get better performance. And at some point, you will see it sort of, even out, and you'll see, okay, I've added more, but it's not giving me more. So then you kind of, what is the best fit? So it's one thing we can't, if you give us only a certain value, I think the autonomic algorithm, STMM, could probably choose a bigger value, but for whatever reason, it hasn't. I don't know the details on that, but definitely you can always override it, and we just tell you to override it. And, maybe over time as we get feedback, it's probably best not to have to tell you to do that. And it's something that we'll probably look at over time. If it does produce those improvements like I'm saying, then maybe it's something we should look at in the future. But for now, that's our statement.
Got it. Thank you.
Okay, good question. All right, so moving on, next thing. So another thing that we did sort of, I don't want to say in the backup space, but in the recovery space is history file. So the history file is being used more and more, not just from us for rebuilds and automatic rebuild restores, automatic incremental restores. It's also being used for a lot of bookkeeping and scripting to do recovery estimation. Okay, so the one particular customer that really wanted this is they had a big outage a couple of years ago, and they wanted to figure out, how long it would take them to do a restore and roll forward. And so there wasn't, we got progress monitor for when it happens, but there's not really good estimations. But what they felt was a good way of doing things was doing everything based on volumes. Okay, so if you know how big objects are, you kind of can have an estimation on how much throughput your systems have based on past history. And so they can write algorithms based on knowing the object size in terms of how long a restore will take and how long a roll forward will take, because then the archive log files. So in order to do that, one of the big things we did was point number one, which is provide backup image size in the history file. We didn't do it just for backups. We did it for load copies, and we also did it for our log archives. So you'll see there now, you know, for backups and load copies, you can do things to multiple locations. You'll see sequence sizes or per image sizes, and you'll see total sizes. All right, so that will be available to us. Also, a lot of people want to look at their backups and they want to say, hey, is this including logs? Is this an encrypted backup image? Is this compressed? A little bit more attributes, if you want to call it that, for the backup images and the log archives and the load copies. So we added that information now as well. So when you do your list history, you can tell that type of information. And the last thing is also the comment field. So the comment field is used by a lot of people. Some people don't use it, and they're like, what's the big deal? But a lot of people use it for tagging. So if they do a backup before a migration, or they're doing a backup before a new application comes in the system, or before an OS change or something like that, they, instead of relying on timestamp, they can go in and update the comment field and make a statement that says, hey, you know, this is before we upgraded the OS, you know, something like that. As well, when you do log archives to vendors, and you have a log arc ops field, the log arc ops field can be up to 254 characters or 256, but the comment field for the history is 30. Well, we need those options when we have to do auto pruning, when we do, you know, having to delete those objects later. And when we couldn't write the full log arc ops, we weren't able to properly delete those objects. So increasing the comment size to 254 to at least allow for the log arc ops to be stored in there gives also users the capability to do the tagging that they were requiring as well. Okay. So really that's what we did. This is what it looks like in terms of, you know, I talked about the total size, the sequence size, compressions. We have various different compression libraries. There's not compressed, obviously, our default compression library, something that the user supplied to us, and also our NX842 and our zlib hardware compression. And the same goes, you know, we have encrypted as well, whether it's encrypted or not, include logs. The same thing goes all the way through for load copy and log files. So we have to support both list history and the table function, DB2 history and min DB history. I forget the name off the top of my head. But pretty much this is what you have for an online backup image. So when you come back, you can query, you get the total size. This was a backup that was done using 3 directories or 3 sessions. So we have a total size, then we have each one broken up. We can see this was compressed using zlib, compressed using zlib. It's also encrypted. So it was using our encrypted library and our zlib compressed library, and it also was an online backup, and by default that includes logs. Okay, so you now see all that information. The same goes for log archives. Log archives is a little bit less, only because there's no concept of sequences, so you only see a total size. But the same thing, it's compressed, so it's using our compressed library. And then for list history, obviously different output, but the same sort of information is supplied to you. You can see the total size is there, and the compression and encrypted is there as well. Okay. On top of that now, so that was 12.1, the changes that we did to the history file. Another version was another customer wanted things not just from the history file, they wanted to do better inventory management in TSM, or what we used to call TSM, now it's IBM, I think. Storage Protect, Spectrum Protect. They changed the name always. We just stick with TSM. That's what it was. Actually, it was ADSM when I started. But anyways, TSM was the bulk of the year, so we still call it TSM. Our syntax is TSM. So DB2 ADTL is a tool that specifically helps to manage backup images, load copy images, and log archives. And so with that, beforehand, we used to just supply, you know, timestamps, what log files, what partition, members, how many sessions it was used. But again, for inventory reasons, for estimation reasons, we can get information based on the sizes up there. So we can see how much data is being stored in the TSM server. Some users don't have access to the TSM server to gain this information. So as a DBA, sometimes you're asked, you know, how much space is being used up there, and you want to make sure that you're not blowing out the TSM server. So this is all sort of what I call inventory tracking enhancements. You can build scripting on that as well for estimations if you want. And so here it is. There's a screenshot. Shows you what the data looks like. This is new as of mod 2, so a couple of weeks ago. The key thing is if you do have scripting built around the ADUTL output, this is the new default. So if you have anything that's based on, you know, regular expressions, this will alter your regular expressions. So be prepared for that and make the changes necessary. But anyways, this is what you get new for mod 2. If you're in GA, you still don't get this information, but you know, mod 2 is tried and tested a long time. We went through a good cycle on that as well. So that's something to look at if you are moving to 12.1. So another thing with log archives, we took a lot of, we had a lot of tough problems. It's not that we took a lot of them. We had a lot of tough problems over the years with customers coming to us and they need to include logs, replication, recovery, roll forwards, where we had to retrieve the log files. And when we retrieved the log files, we'd get IO errors, all right? And those are bad because obviously that was a hole. The archives is usually your only copy for your historic data. So when there's a problem with the archives, you got a data loss situation, okay? So a lot of times those types of problems are very, you know, obviously very bad. And when they come to us, it's like an oh crap kind of moment. What do we do? What happened? Is it DB2? Is it the vendor? Is it the disk system that the log archives are on? Typically, if you're using disk, your log archives should be on a separate file system than your active files. So your active files can be perfectly fine, but you could have some sort of sector problems on your archived disk. Your vendor, well, you could have problems in your vendor. We see it less with vendor. We've seen it more with disk, okay? But so what ends up happening is what's going on here? Did we archive the file incorrectly? Was the file already bad when we put it in the archives, or did the problem happen after archiving? Okay, so that was always the question. And I don't want to say it's like, is it a DB2 fault or not? But yeah, because like the blame would be always on DB2, and we had no mechanism to say whether you know, the user's file systems were the problem or DB2 logical problems we had. So we added this in the 11.5. I forget exactly where, but it was an internal registry variable. We had the same problem as well in system tests. Sometimes this happened from time to time. So this was used primarily internally to start off with to understand what's going on internally. But now it had such good usage that it helped us to figure out, you know, those problems of where the problem lies. We made it fully usable for our users. So what you'll see now is some of you may be familiar already with the tool DB2 checklog, very similar to ADUTL, but only for log files. So checklog works for anything on local disk, can go out and validate that a log file is sane. You know, like there's no page problems, no integrity issues, things like that. So what we do now is every time we archive a log file, we run internal checklog on the file to make sure that everything adds up and the file looks good as it leaves DB2 and goes out into the buffer stream and out into wherever the archive location is, okay? So it's on by default. There is, again, a registry variable to turn it off. Really all we're doing is we go through. So normally when you do archives, there's two types of problems you can have with an archive. You can have a target problem, which is, let's say the vendor's not available, so we retry. And then we go out to fail arc path if you have it set and move on. Or what happens is you have a source problem. We never had good detection for the source problem. We have the mechanism for the target problem. So this feature builds on top of that, but now is aimed at the source problem. So what will happen is we start reading the file from the active path or the fail arc. If there are problems with that file, we'll keep trying up to num retries amount of times. And if the file is bad, we will still write it out to the archives, but we will make a notification, an alert if you want to call it, you'll see in a second, that notifies you there's an ADM message, there's an update to the history file, there's something in DB2 PD-logs. You will be made aware that you've had an log file fail archive validation. And what that means is that's supposed to alert you because that now means that if you need to use this file for any form of recovery, even rollback with infinite logging, rollback normally under non-infinite, you have all the files local as well, so you have that duplication, so that won't be a problem. But if you need it for like include logs down the road because the low trend moved up, min buff moved up, or if you need it for replication or roll forward is the main use case, you now know that there's a hole in your system and you should take a new backup as soon as possible, okay? A new backup, first of all, you got to move up your head extent. So you'll have to figure out that, okay, I got a bunch of long-running transactions or my flushing's behind, but I got a hole now since that oldest recovery starting point. So you got to get that value moved up. We can't do that for you. So all we can do is alert you, and now it's the user's responsibility to get rid of any long-running transactions, make sure flushing is moved up with a flush buffer pool call, and then take that new backup as soon as possible. That's going to move up head extent over the hole, over the bad file, and now that will save you from any future data loss if there is a recovery need. Okay, so it's not a foolproof system to help you avoid it, but it definitely helps you alert yourself to pending problems. Okay, and that's the goal of this feature. As you can see, like I said, here's an example of a list history statement. We add to the very beginning of the comment field this VE, so validation error, if you want to call it. What we came up with. It's based on what we did here. That was the easiest way rather than add a new field. So you'll see this. This is just an example with logarc ops, and the second one doesn't have logarc ops, so we just add that. So if you see that, that's one indicator. The second indicator, which hopefully you'll see even more so, is the ADM message. Okay, so the ADM message will get written, telling you all the things that I just said. And then secondly, if you have monitoring, I always suggest this to customers. If you should always have some form of monitoring, either through the UDF, the mon get transaction log, or through dash logs, DB2PD dash logs. One of the two you should always kind of have running in a repetitive fashion. Hopefully you can run some scripting on top of that alerts you to log archive problems. I think you'll see in a second. You can tell when you have a log archive problem. You can tell when you have a writing problem or where the writing is taking place. And now you can tell when there's a validation problem with our log archives. So here's what I was saying. This is what we use internally a lot, but it's available for everyone. Here it can tell you the status, archive status. You can look at that. Here's the last log validation error. It tells you what the file that's bad is, so you know where the hole is going to be. And here it tells you the rest of the sort of active log position. All right. So this is something to take a look at. Like I said, moving to 12.1, you get this for free. So extra validation. That's hopefully always a good thing. A couple of last notes on it. We keep it in sync. So if you're in an HADR system, we supply that information from the primary to the standby to make sure both sides are aware of it. So if you do a takeover, that after the takeover on the new primary, you're still alerted to the problem because they do share the same files. And if you do any pruning and the pruning leaps over the hole, then obviously we'll clean out all the information so that we reset everything. And we only report the last one. So what I mean by that is if you had your bad luck and you had validation problem on log 5 and file 10, we're only going to tell you that 10 is the problem. Okay. We're not going to tell you that 5, 10, and whatever is the problem. We're only going to tell you the last one. All right. So that's hopefully goodness. Mohan, again, we'll just check. Any questions? No. All right. We'll move on. If there's anything, we'll catch it in the next one. So the next thing with log archiving, we came out with support for object store remote storage, DB2 remote, the alias concept. So the alias concept came out sometime a little while ago. We then extended remote storage for log archives. We had it for backup, we had it for load copies, but now we can do it for log archiving as of 11.5.8. When this came out, there's two types of ways to write to remote storage. I guess reading as well, but this is mainly going to be on the right side. Is our default way is everything has to use local storage. So we write all the data that gets accumulated on the local server, and then when ready, I'll just generalize it like that. When ready, the data gets pushed out over to the remote storage object store vendor, if you want to call it that, if it's AWS, IBM costs, and now we do Azure. So we used to use the staging area for both archive and retrieve. That isn't ideal because the data is being buffered, so to speak. It's always buffered writes. So that takes a little bit longer from start to finish on how long it takes to archive a log file. So what we did now for mod 2, so 12.1.2, all our log archives are now being streamed. So as soon as we write, there's no longer a staging area. It goes straight onto the channel. There will be some buffering in memory, but that is a much more optimized handling system, if you want to call it that. And that data is going to get pushed through the cloud right out to your object store vendor. We've been seeing about a 10 to 20% reduction in log archive times just by moving to streaming. All right, so that allows us to push the data out to the archives quicker. That's also a good thing because that means we're not storing the files longer in the active paths as well. So a lot of times what we saw, especially if you have bad network bandwidth, is we get a lot of pending archives. So as head extent moves up, we can't reuse files until we completely archive the file. So if your archive location is slow, these files will accumulate even when first active file is up high. And so we call that pending archives. And so we saw that quite often in slow networks. But now with the streaming, that allows us to push the data through quicker, which means the files get archived quicker, which now means we can reuse the active files quicker, which now means less storage requirements on the active path and less likelihood of running into physical disk full problems. Okay, so that's again a good thing. A lot of customers, they run sort of like their own scripts to do their own log file management, which is really a bad idea. And if you do that, you should see one of my other slide decks you can see on my LinkedIn profile, which talks about auto pruning. But definitely, this is a good one altogether. Log retrieve still do the staging area. There's some performance enhancements in the general infrastructure with streaming on reads from remote storage. So that's something that's in our long-term picture. But right now, the key was we want to get that data out of the active path as quickly as possible. So definitely going streaming for archiving was our main focal point. Another big availability thing that we did is in HADR upgrades. So I think around 11.1, we came out with the ability to do HADR upgrades while keeping the connection. So no need to reinitialize your standby. You can do your upgrade on the primary, the standby, and the whole upgrade is recoverable. The logs get shipped over, and you can keep your connection. All right. So like I said, avoid reinitialization. So what we did for 12.1 is there was a use case that came to us from a customer where they want to do more with the standby. Everyone wants to do more with the standby. We get it. We understand it. Incrementally, we're chipping away at it. So in this situation, the customer has reads on standby, and they're like, while the upgrade is going on, I can't have any, obviously no write workload can go on because I'm in the upgrade, but I want to still be able to service read applications on the standby, okay? But our problem is once we're in upgrade mode, we don't allow any other connections on the database. So we came up with a mechanism using the existing major version upgrade procedure where you can upgrade the primary to 12.1, but you can leave the standby down level in 11.5 or 11.1, and at the same time, you can have read-only applications connect, ROS-only applications connect to that standby and gain data, all right? So to be able to do that, again, the whole procedure does not need reinitialization of the standby. We can keep informed communication. The key with this particular feature, if you want the reads on standby capability, is you must move up to 11. Mod 8 or Mod 9, and you must pick up this CSB level or this APAR level or KI, I think we call it now, okay? Most of the latest Mod 8s and Mod 9s have this already, so that's not a big deal. But we did have to put a little bit of code in the down level to be able to support this. And really what's going to happen is both the primary and standby do have to validate that they end the major release on the same log data, okay? We still don't have the capability for 12.1 to read and replay 11.5 log records and log data. That is a future item. But we do have the capability now of the primary and standby communicating with one another and understanding, you know, the different language of a down level and up level language. So we do have that. That was built with this. So while we do this, there's a whole procedure. Again, I have another one that you can find on my LinkedIn profile that talks about HADR major upgrades and how that procedure is done. But pretty much what you can do is you make sure your primary and standby are at the same level using check upgrade or I upgrade. And then once you get the okay on the primary side that the standby has replayed everything from the primary, you can bring the primary down, install and start the upgrade procedure there. On the standby, you can leave it at the 11.5 level. You can let it stay activated and service the read requests while the primary goes on and does the upgrade. All right. Now, what will happen or what will not happen during this time frame is log shipping. Okay. In order to do log shipping, we still do need the primary and standby to be at the same major release level. So what will happen is while we're doing this procedure, there will be a log gap that is forming that covers the upgrade window. But based on the use case scenario and the customers that we talk to, they're willing to take that sort of quirk, if you want to call it that, in exchange for having the availability of servicing read-only applications. And so once the upgrade is done on the primary, then you can pretty much bring the standby up to the new level and upgrade it. It's going to play catch up on all the log shipping and all the log data that was written during upgrade. And then eventually it will be at the 12.1 level, and then read-only support can happen again on the standbys.